Okay, so for number 4, we've got x cubed again, so we've got 3 total solutions that we should find when we're all said and done. So let's go ahead and really, if we're given the opportunity to graph, that's always going to be our first step to see what we can pull from the graph and then go from there. So I'm going to go to the calculator and graph x cubed minus 5x squared plus 7x minus 35. So I'll clear out that one if there is anything in there. And we'll do x to the third minus 5x squared plus 7x minus 35. And graph it. Okay, so it looks like a straight line, right? So I'll zoom in if you guys are doing this on your calculator. We're actually way down here at like negative like 32 maybe, where it does sort of like turn a little bit. So it's not a straight line, but there's only one real number solution or one real zero on the x-axis, and that's up there at the top. So it's right in between 0 and 10. So that x value is 5. Again, if you guys go to your calculator or to your table, the only place where y is 0 is also at the x value of 5. So we know that 5 should be a solution, and if we divide this polynomial by 5, we shouldn't get a remainder. But we're going to have to figure out what those other two solutions are. If they're not on the x-axis, that just means they're imaginary, and we're going to have to solve for them by using the quadratic formula. So let's start by dividing by 5. Since we know that one should be a solution, and when we divide by 5, it's going to go from an x cubed to an x squared. Every time we divide, it goes down a degree. So 1x cubed negative 5x squared, 7x minus 35. So bring down the first one. 5 times 1 is 5. Negative 5 plus 5 is 0. 5 times 0 is 0. 7 plus 0 is 7. And then 5 times 7 is 35. So we do end up with no remainder. So 0 is the remainder, 7 is your constant, 0x, 1 is x squared. So the polynomial you guys are left with is a squared. It just so happens that your b term is going to be 0, which is fine. So if we use our quadratic formula, we already know that 5 is one of our solutions, but we need to figure out the other two. So let's plug in our a, b, and c to find our x value. So it seems kind of silly, but we're still going to write negative our b value, which is 0, plus or minus. Remember, the plus or minus, guys, means that that's how you get two answers from this quadratic formula. Plus whatever's under the square root and minus whatever is under the square root. So b squared, 0 squared, that'll be easy. Minus 4 times a, which is 1, times c, which is 7, all over 2 times a, which is 1. So let's simplify this. So we get 0, so I'm not going to write that. I'm just going to write plus or minus, or positive and negative. 0 squared is 0. So negative 4 times 1 times 7 is negative 28. All over 2. So we need to simplify the square root of 28. I know that I'm going to have an I because of your negative. Anytime you have a negative, that's what becomes your I on the outside. So we just need to worry about simplifying 28. So I would use 7 and 4, and then 4 would be 2 and 2. So that pair of 2's is your perfect square. That's going to come out, and you're left with 7 underneath. So the only thing you guys have to do is just make sure you can't reduce this any further. So if I'm looking at this and I see 2 over 2, 2 over 2 is reducible to just 1. So what happens is that is going to go away or become 1. So x is going to equal positive or negative I square root 7. So that's really two answers. That is positive I square root 7 and negative I square root 7. We also have our solution of 5 that we found from the graph. So if you're a visual person and you like to write like all of your solutions out instead of writing them together as plus or minus so you can physically see all of them, that is fine. But your three solutions to this polynomial are going to be positive I square root 7, negative I square root 7, and 5. Two imaginary, one real, total of 3.